Hey guys, in this lesson we're going to talk about the polygon sum conjecture and two other elements. In the first part, I have a polygon and we're going to go ahead and find the measure of the sum of all of the angles. So what we want to start off with is understanding that a polygon, okay, has many sides. And we're going to use the fact that a triangle has uh, the angles of a triangle all add up to 180. And if you notice what I did here is I have a polygon that has 1, 2, 3, 4, 5 sides. And what I did is I made triangles. So from here I made this triangle and then this triangle and then have 1, 2, 3, 3 triangles. And each of them is 180, 180, 180. So we have 3 triangles, each of them 180 degrees for a total of 540 degrees. And what that means is that each angle A, B, C, D, E, if I add up all of these angles, it should equal to 540 degrees. And that basically is the gist of the polygon sum conjecture. Okay? And let's say go ahead and do another one here. So for example, see this polygon has 1, 2, 3, 4, 5, 6 sides and it has 6 angles, right? If I do this, that's one triangle. That's the second triangle. And then that's another triangle. So we have 1, 2, 3, actually 4 triangles that I made. Okay. So here's the first triangle, the second, the third, and the fourth. So we would have 4 triangles, each of them 180. Okay. And that'd be 40 and 32. That means the total is going to be 720 degrees. And actually, there's a shortcut that we can tell here. If the shortcut here, or the formula, I guess you can say, is you notice we have 1, 2, 3, 4, 5 sides. Okay, so we take the number of sides, subtract 2, and then we multiply it times 180. Okay, times 180 degrees. So for this guy right here, we have 1, 2, 3, 4, 5, 6 sides. 6 take away 2, and you have 4 triangles. Okay, and that would be the formula right here as well. So we're going to go ahead and use that just to sometimes just make it easier for ourselves, but that's what it is. And knowing that, we can go ahead and apply it. And remember, we're still using everything that we know from before. We know that a straight line adds up to 180. So we have 180 minus 72 degrees. Right here is a straight line. And that means that's going to give me 108 degrees. So that means letter B is 108 degrees. Okay. And then this guy right here, we know that one's 90 degrees. And we know that this is 1, 2, 3, 4, 5. 5 sides. Now you see these here are the same, right? The little symbols right here, the red symbols. That means this guy's also 120 degrees. Okay, now this guy has 5 sides. And 5 sides, that means 5 minus 2 times 180. That means we have 3 triangles times 180 degrees. That means the total is going to be 540 degrees. That means that if I add up all of these angles, it should equal up to 540. So that means angle A plus the 120 plus the other 120 plus the 90 and plus angle B, which we found out is 108, that should all equal to 540 degrees. That's what that means. And so that's just 240 plus 90. Okay, that'll give us 330. 330 plus 108, that is equal to 540 degrees. Okay, and then this would give you 438. And plus A is equal to 540. And that means when we do the math and we subtract, it looks like that's going to be 102 degrees. Okay, so angle A is 102 degrees. But you notice what I did is I used the fact that it has 5 sides and all of these angles combined is going to give me 540 degrees. Okay, so that's what you want to go ahead and do. And you just want to continue to apply all that we know about all this and kind of piece the puzzle together. Looking at this next example, you notice that we have an isosceles triangle right here. So we have, see these little markings right here? That means that these two sides are the same. Well, if these two sides are the same, that means these two angles beneath it are the same too. So we know that a triangle is equal to 180. So 180 minus 26 degrees, okay, that's going to equal to, that's what, 454 degrees. And if we divide that into two equal angles, okay, 154 divided by 2, that means each of them is going to be equal to 77. All right, so that means this guy right here is 77, and this little guy here is 77. Okay, now if you notice, this guy makes a straight line, so we can go ahead and figure that out. So that means we're going to have 180 minus 77 degrees, and it looks like that's going to be 103 degrees. All right, so letter B is 103 degrees, so that's nice. And what's nice about it, that means letter A is also going to be the same thing, 103 degree as well. All right. All right, and if you notice here, you see these little red markings, remember what that means? That means parallel lines. As soon as you see parallel lines, think about alternate interior, alternate exterior, same side interior, all those properties of parallel lines. Well, these are parallel. That means this guy is a transversal. Okay, what does that mean? That means that this angle right here is the same as this angle right here. These are alternate interior angles, okay? One's on the right, one's on the left, and they're inside between the parallel lines. That means angle C, that means that angle C is also 97 degrees. All right, and then angle D, we can do 180 minus 97. Let's see here, 180 minus 97. And that looks like it's going to be 83 degrees. Okay, so angle D will be 83 degrees. All right, now we can also figure out letter E. So remember, this is 1, 2, 3, 4, 5. You got 1, 2, 3, 4, 5 angles, 5 sides. So if I have 5 angles or 5 sides minus 2, which is our formula, times 180. 5 minus 2 is 3 times 180. That means the sum should equal to 540 degrees. So that means A plus B plus C plus D plus E should equal to 540. Well, we found out all of these. So let's see here. So this plus this plus this plus this plus angle E should equal to 540. So this is going to give me 206 plus 97 plus 83 plus angle E. That should all equal to 540 degrees. Okay, so 206 plus 97, that would be, what is that, 300 and, that's 5, 6, that'd be 9, 305, I believe. No, 303 actually. That'd be 303 plus another 83 plus angle E is equal to 540. So 303 degrees plus 83, that would be 386 plus angle E, that's 540. And then when you do the math, it looks like you're going to get, see, angle E, 540 minus 386. Just be careful. And what is that? This becomes a 10, that becomes a 3, 4, borrow it again, and it's at 154, looks like it. So angle E would be 154 degrees. All right, guys. And so you notice all I'm doing is just using all my properties that I know and incorporating it into this new conjecture that I'm using. But remember, all I'm doing is adding all of these should equal to 540. Where did I get 540? Well, remember, all of these angles. 5 minus 2 is 3. It makes 3 triangles times 180. That means all of them should add up to 540. Okay, let's do another one. This is a word problem though. It says the sum of the measures of the interior angles of a regular polygon. And I want you to look at something really careful here, the word regular. The word regular means that all the sides are equal, all the angles are equal, okay? And that means it's going to equal to 2,340 degrees. And it says, how many sides does a polygon have? Okay, so think about it. You have a polygon, okay? I don't know how many sides it has. And we'll just kind of draw something just for all intents and purposes, all right? The sum of the measures, this guy's right here, if I add up all these angles on the inside, is 2,340 degrees. I don't know how many sides it has, but I just know that when I add them all up, it has to equal to 2,340. How many sides does the polygon have? Well, I can use my formula. So I know n minus 2, I don't know how many sides it has, times 180. That should equal to 2,340 degrees. Okay, so I'm trying to figure out the number of sides. That's what I'm trying to do. Well, let's just go ahead and do a little bit of math. I can go ahead and divide by 180. Divide by 180. And that's going to simplify out. You're going to be left with n minus 2 is equal to 234 divided by 18. 234 divided by 18. All right. Remember, see how the zeros cancel out. How many times 18 go into 23? That'll be once. And looks like it's going to be 13. All right. And just basic division. And then we're going to add 2 to both sides. Just like that. That means the number of sides of this polygon is 15 sides. But you notice, what did I do? I just used my formula here, my n minus 2 times 180. Okay, again, the sum of the measures of the interior angles of a regular polygon is 2340. So I'm now adding all of these, okay, it should equal to 2,340. And I just used this conjecture here. I did a little bit of division, and I ended up to get 15. All right. So that's the conjecture, the polygon sum conjecture. And that's pretty simple. The next one I want to show you is the exterior angles polygon, and this one's even more, okay, much more easily doable. All it says is that the exterior angles, okay, all of the outside angles, the ones on the exterior, the outside, all of them for any polygon, they're always going to add up to 360. That's easy. That's the beauty of it, okay? That's nice. So it doesn't matter how many sides it has. So remember, first we talked about the inside, right? All of these. But now we know that all the angles on the outside, when we add them all together, it has to equal to 360. So let's go ahead and do some of these questions. What's the sum of the measures of exterior angles of a hexagon? Okay, so it's telling us, okay, if you have a hexagon, and if you add up all the exterior angles, all the angles on the outside, how much is that going to add up to? Well, that's easy. They're all going to add up to the same thing, 360 degrees. It doesn't matter if it's 5 sides, 6 sides, 7 sides, 8 sides, 9 sides. It's all going to add up to 360. Now remember, this is only for the outside angles, the exterior angles, okay? All right, number 2. What's the measure of an exterior angle? Okay, that means only one, okay, not the total. What's the measure of an exterior angle of an equiangular hexagon? Okay, equiangular, that means all the angles are the same. Hexagon, remember how many sides a hexagon has? A hexagon has 6 sides. Okay, so remember, all the way around, we have 360. So how much is each one if they're all equal and it has 6 sides? Well, that's not very difficult, is it, right? You take 360, divide it into 6 equal sides. That means each angle of a hexagon is going to be 60 degrees. What about an octagon? Well, an octagon has 8 sides. That means that we're going to take 360 divided into 8 equal sides. So how many times is 8 going to 36? That's going to be 4. 32, 40, that's going to be 45 degrees. That means for an octagon, it has 8 sides. All 8 sides, let's say this is 8 sides, right? All the outside is going to, each angle is going to be 45 because that'll give me 360 degrees. And all I did is I take the 360, I divided it into the equal number of sides or angles. All right, guys? Number 3, how many sides does a regular polygon? Do you see that? The word again, regular. The word regular means it's all the sides are the same, all the angles are the same, okay? So how many sides does a regular polygon have if each exterior angle measures 20 degrees? Okay, remember all the sides are the same, all the angles are the same, the outside, okay? So I mean, I know each angle is 360 degrees. Okay, and each angle is going to be 20 degrees. So, okay, so I divided by 20, and that's going to give me 18. So that's going to give me 18 sides. Okay, so this polygon has 18 sides, and each of the outside angles, okay, each of the outside angles is going to measure 20 degrees, and that's going to give me 18 sides. Okay, guys, so hopefully that makes sense. So remember, all the exterior angles, the outside angles, always adds up to 360. And let's do another one. All right, this one right here. And if you notice, you see we're talking about the outside angles here. See, this is all the inside. Now we're just looking at the outside. Okay, so this is 82, 68, 70. We don't know what this guy is, huh? We don't know what this guy is right here. But can I figure it out? Absolutely. See here, this is a straight line. So we have 180 minus 150. That's going to give us 30 degrees. So this guy on the outside is going to be 30 degrees. And now we can find out the value of x. Now remember, all the exterior angle all has to add up to what? 360. That's right. So we have x plus 82 plus 68 plus 70 plus 30 has to equal to 360. Remember, we're talking about the outside angles, not the inside. We already did the inside. We're only talking about the outside angles, the exterior angles, okay? All right, so let's do some math. So let's see here, 82 and 68, 14, 15, that looks like it's gonna give me 150 degrees. This is also gonna give me 100 degrees. That's equals to 360. So this is going to give me x plus, that's going to give me 250 degrees equals 360. And when we do the math, looks like x is going to equal to 110 degrees. All right, and that's would be the measure of that angle x. All right, nice. Simple, simple, simple. So hopefully that makes sense, guys. The last element or property that I'm going to share with you is about mid segments, okay? So what are mid segments? Okay, and we're just going to do 2, triangles and trapezoids. Very, very easy. A segment connects the midpoints of a triangle or a trapezoid. Now remember, what's a midpoint? It's the middle, right? And what happens? It cuts it in half. That means that this side is equal to this side, right? You see that? So this guy is a mid segment, and this is the midpoint. That means this cuts it into half. So for this guy here, this side is equal to this side. And over here on this side is equal to this side. And then for this third side, this side is equal to this side. And what happens is when you connect all these mid segments of a triangle, you have 4 congruent triangles. And that's pretty cool. Okay? And that's the first thing I want you guys to take a look at. All right? And then the next part is the mid segment, okay? The mid segment is parallel to the third side, and you can kind of tell right here, okay? But I want you to notice the mid segment is parallel. So you're gonna often see the little arrows there like that. And that's important because if you have parallel lines, then you can start using alternate interior, alternate exterior, all those properties of parallel lines. But the other thing that is important, and that's why I circled it, the mid segment, okay, listen carefully, the mid segment is half the length of the third side, okay, half. So whatever this side here is, this long side here at the bottom, well, the mid segment is always going to be half of it. And that's pretty easy. And that's pretty straightforward. And we'll do some examples. And that's for triangles. And the last one is a trapezoid, okay? Now, a trapezoid, as you've learned, has two bases. We have this base on the top. We'll call that base 1. And then this base on the bottom, base 2. And then remember, it's also a mid-segment. So this line right here is a mid-segment. So which means it divides this guy here. This is the midpoint. It divides it into two equal halves. So this half with this half here. And then on this side here, this part over here, this half is equal to this half. Okay. And so we know that the mid-segment is parallel to the bases. So this side here is parallel to these bases right here. So we can do this. These guys are parallel. These guys are all parallel. And that's important because remember, parallel line means what? Alternate interior, alternate exterior, all those good properties, okay? Okay, and the last part, which is number 2, is this mid-segment right here. This mid-segment is the average of the base lengths. So what does that mean? Well, to figure out this distance here, all I do is take the average of the bases. Well, how do you do that? Well, you add the bases and divide them by 2. That's it. So you can write it like this, or if you want to write it like this, that's perfectly fine too. But that's how you figure out the length of this mid-segment. You add the bases, this base plus this base divided by 2, and that gives you this length right here. So let's go ahead and do some examples here. All right. See if we can do some examples here. So now remember, what do we notice? All of these are mid-segments. So this is a triangle, and we notice that these are all mid-segments. So this guy is a mid-segment. Okay. Now remember, that means these guys are parallel. The mid-segments are parallel. So because of that, okay, see, these are parallel lines. Okay, that means this guy right here, this guy is like a transversal. It's the line that cuts it. So that means that this angle here, 54 degrees, corresponds to this angle right here. So remember, these are parallel lines. Remember the corresponding angles. So B is congruent to 54. Why? Because corresponding angles of parallel lines, okay? So remember, when you see mid-segments, you gotta understand you have these parallel line segments. So I'm able to figure out letter B. Okay, now what about letter C, angle C? Well, if this is 37, this is 54, we can figure out this triangle. So I can actually figure out this little angle right there, all right? So we know, let's see here, 54 plus 37, that's gonna equal to 891 degrees. Okay, and then we have 180 minus 91 is equal to 89 degrees. Okay, so this little guy right here is 89 degrees. Okay, and that means I can figure out angle C. So 180 minus 89. Okay. So it'll end up being 91 degrees. And if you notice here, these are parallel lines here. So if these are parallel lines, that means the angle A and this angle here are corresponding. Meaning if this guy is 89 degrees, then angle A would also be 89 degrees. And that's how we would get that one. Now over here, for example, too, if you notice this guy here is a midpoint, okay? That means, remember, this is the mid segment, this is the midpoint. So if this guy is 16, that means this guy over here is also 16. So 16 and 16 would make Z 32. And we said here, this mid-segment, excuse me, this mid-segment here is half of this large one here, which is 14. So if this guy's 14, this guy here would be 7, okay? And then lastly here, we have another one. This is also a midpoint here. Remember, these are all mid segments. So if this guy's 21, that means X is also 21. And that's it. And that's not too bad, is it? All right, now let's do a trapezoid. The trapezoid, same thing here. This guy's a mid segment. That means if this guy's 11, that means Y is also going to be 11. Okay. And then here, if this guy is 13, remember, this is the midpoint. This is the middle. So 13, this whole thing here all the way across is 13. So if we divide 13 into 2 equal parts, we are going to get 6.5. So that means Z is 6.5. And sometimes we do get a decimal, and that's okay. Lastly, we need to find the value of X. Now, this one's a little bit tricky, but remember what we said. For this guy here, this mid-segment here, in order to get this mid-segment here, we're going to take the average of the bases. This long base plus this short base divided into 2 will give us this mid-segment here. So 41 plus X, 41 plus this guy. If we take the average, that means if we divide it in 2, we should get the middle segment, which in this case is 29. Okay, and then what do? I can cross multiply. I get 41 plus X is equal to, what is that? 58. Looks like it's 58. And if we do the math, X is equal to 17. All right. And there it is, X equals 17. All right. So not too difficult, very, very straightforward. Let's go ahead and do one more. A little bit more difficult, okay? And it says X, Y, and Z are midpoints. And that's the key right here, midpoints, okay? And what you want to do is you want to start labeling these, okay? The perimeter of triangle PQR is 132, so PQR, so all the way around is 132. RQ is 55, so that means this whole guy right here is 55, okay? And PZ is equal to 20. So from P to Z is 20, right there. That means that from Z to R is also 20, right? Because this is the midpoint. Okay, if RQ is 55, I'm going to go ahead and divide that into 2 equal parts. And that's going to give me, what is that? 2, 15, 26.5, 27.5. Is that right? Let's do that the long way. 2 goes into 5, 2. 1, 15, that would be 7. Yep, 14. And it's 27.5. So each one here, this guy over here is 27.5. And this guy is 27.5. Okay. Now if you notice, we almost go all the way around, huh? So remember, the perimeter of triangle PQR is 132. So PQR all the way around the big triangle is 132. So this guy here is 40, okay? Plus this whole length here is 55, plus the length of PQ, which I don't know. That all should equal to 132. We're going to get 95 plus PQ is equal to 132. And we're going to subtract 95 on both sides. Okay. And PQ, what is that? 737 looks like. So from P to Q, it's going to be 37. And that is kind of interesting, isn't it? All right. So over here, PQ is equal to 37. And sometimes it just happens that way. Okay. And then we have to find ZX. Okay, let's see here. I think I'm going to have to divide this guy in half. So what is half of 37 here? And I just want to make sure, because 37 is an odd number, but it looks like we did it right. So that's 40. This guy is 55. 40 and 55 is 95. And it just happens to be an odd number, and that's okay. So this guy's going to be 18. 1. Okay. And that's 8. 16. Okay. 0.0. So it's going to be 18.5. So this guy's 18.5. This guy's 18.5. Alrighty. All right, so now I can almost figure it out, okay? What is ZX? This guy right here, what is this guy here? Well, remember, this guy, this segment right here is half of this longer segment right here. So this whole segment is 55. That means this segment here is going to be half of 55, which is 27.5. Right here, 27.5. If you notice here, remember this segment here is going to be half of this longer segment here, which is going to be, let's see here, 27.5. Okay, this segment over here is going to be half of this long segment over here. So remember, this long segment is 37. Half of it would be 18.5. Okay, and then this segment here is going to be half of this long one here, which is going to be 20. Okay, and hopefully that makes sense, right? This guy's 40, half of this is 20. And now we can figure out the perimeter of triangle XYZ, XYZ. So 20, 18.5, and 27.5. And let me do this in blue. So we got 20 plus 18.5 plus 27.5. And that's going to give me 38.5 plus 27.5. And that's 516.5. So it's 66. So the perimeter of triangle XYZ is going to be 66. Okay. So hopefully, guys, that helps you out and gives you enough examples to go ahead and understand it. All right, guys. We'll see you guys next time.